Okay, hello everyone. Since we have already covered Ohm's law and drift velocity, now moving forward, we'll discuss resistance and the factors on which value of resistance of a wire depends, and also how to calculate resistance when different parameters are changing or when different parameters are given. So all these things we'll be covering in this lecture. Okay, so remember in a wire, atoms are stationary and electrons are continuously moving. So electrons collide with atoms when they drift from negative to positive terminal. So if there is collision, so this means that basically there is a resistance in between. So on what factors does this resistance depends and how resistance changes, so you have to see. So suppose we have a wire of length L and area of cross section A. Now if you'll see that suppose the length of wire is small. Suppose this is length L1. So an electron has to collide with suppose only 4 atoms, and suppose now I increase the length. Now the atoms that there will be in between will increase. So now electrons, in first case electron has to collide with 4 atoms. In second case it has to collide with more number of atoms. So resistance is directly proportional to length. Similarly, if you will see, suppose 3 electrons have to pass from this area of cross section, this one. Now if you will see, negative charge repel negative charge, so they all will be repelling each other, but they have to pass this cross section simultaneously. So there will be some kind of resistance. And suppose I increase the area of cross section. Suppose now area is increased. Now if you will see, electrons can travel more freely because they are away from each other. So force between them will be less. So if you will increase the area, then resistance will decrease. So resistance depends on length and resistance depends on area. Similarly, there is one more parameter, that is number of electrons. So if it is a metal, then the electrons will be more. If it is insulator, then electrons will be less. Similarly, there is another factor, that is tau, that is relaxation time, that we have already discussed in drift velocity. So this all are parameters other than dimension, and all these parameters combine to form this parameter, that is resistivity. So resistance is directly proportional to resistivity. So more the resistivity, more will be the resistance. So if we will combine all three formulas, then we'll get R equal to rho L by A. That is, resistance is equal to resistivity into length divided by area. So you can see in this slide how this formula has been formed. So resistance directly proportional to length, resistance inversely proportional to area, and resistance directly proportional to resistivity. So combining all this, we have R equal to rho L by A. Now if you'll see, value of resistance depends on resistivity, length, and area. But resistivity is independent of length and area. Resistivity depends on type of material, temperature, and other external factors. So remember, for metals, resistivity is directly proportional to temperature, only for metals. So you have to remember that resistance depends on resistivity, length, and area, but resistivity is independent of length and area. So resistivity depends on type of material, temperature, and external factors. Also, the formula can have other variants. Suppose the diameter of wire is given, so radius will be d by 2 and area is what, pi r square. So area will be pi into d square by 4. So putting value of area in the formula, that is r equal to rho L by A. So basically at the place of area we can write pi r square also, or if we put r equal to d by 2, then the formula becomes rho L4 divided by pi d square. So you have to remember all these variants because all these variants are very important of all the formulas. Now also there is an important thing, that is SI unit of resistivity. So how to find out SI unit of resistivity? Since we know that resistance is equal to rho L divided by A. So basically resistance, SI unit of resistance is ohm. We have to find out resistance of resistivity. SI unit of resistivity, so length is meter and area is what, meter square. So M and M will get cancelled out. So resistivity will be ohm meter. So you have to learn this thing, SI unit of resistivity. Now this is one important topic related to MCQ type of questions. So how will resistance change when wires stretched? Suppose we have a wire of area of cross section A, length L and resistivity rho. So resistance will be rho L by A. Suppose I increase the length from L to 2L. So definitely if we'll increase the length, then area will decrease. So you have to now use volume conservation. So previously volume was area into length. Finally the length is 2L and suppose area is A dash. So equalizing both the volume, we have A into L equal to A dash into 2L. L and L will cancel out and A dash will be A by 2. So the new resistance R dash will be, since resistivity will not change, length is 2L and area is A dash. Putting value of A dash to be A by 2, this 2 will come upwards and the resistance will become 4 times. So you have to remember that if length is increased to double, resistance will become 4 times. If length is increased to 3 times, resistance will become 9 times. It is basically square times. So if it is increased by n times, resistance will increase by n square times. Similarly, remember that with increase in temperature, since resistivity will increase, so if resistivity will increase, then resistance will also increase. So suppose at temperature T1, resistance is R1, and at temperature T2, resistance is R2, and if T2 is greater than T1, then R2 will be given by R1 in bracket 1 plus alpha T2 minus T1. Alpha is temperature coefficient of resistivity whose SI unit is Kelvin inverse. Same formula applies for resistivity also because R2 equal to R1, 1 plus alpha T2 minus T1. Here T1 and T2 can be in Celsius or Kelvin. It does not matter because we are only finding the difference. So you have to remember this formula, both resistance and resistivity. Now we'll solve a numerical on the basis of this formula. Suppose at room temperature, that is 27 degrees Celsius, the resistance of a heating element is 100 degrees Celsius, 100 ohm. So at temperature 27 degrees Celsius, resistance is 100 ohm. What is the temperature of the element if the resistance is found to be 117 ohm? So we have been given R2, that is 117 ohm. We have to find T2. Alpha is given in the question. So we have to just put the values in this formula, that is R2 equal to R1, 1 plus alpha T2 minus T1. I have taken this question directly from our NCERT book. If we'll go to big exercises of NCERT book, you will find many questions related to this topic. Okay, similarly we have another question, that a silver wire has a resistance of 2.1 ohm at 27.5 degrees Celsius and a resistance of 2.7 ohm at 100 degrees Celsius. Determine the temperature coefficient of resistivity of silver. So we have T1, we have R1, we have T2, we have R2. So you just have to put the values in this formula, that is R2 equal to R1, 1 plus alpha T2 minus T1. So you can easily find out value of temperature coefficient of resistivity. Okay,